Yeah, nice afternoon to all of you. I hope you can hear us. If you have any problems, please use the chat function, but I suppose everything is working fine. Today, I'd like to welcome you together with Professor Michael Tost. Michael Tost is head of Mining Engineering and Mineral Economics Department in Leoben, and he will speak today about the role of minerals and mining in the sustainability transformation. Michael Tost has long-term experience both in academia and in the industry, and for many years now he's back in Leoben working on sustainability in mining. Yeah, before we start, I'd like to give you a general introduction how typically we conduct our TripleN talks. We will have the presentation now by Michael Tost. The chat function is open today. Michael might ask you some questions. You can answer directly. And also, if you have questions, more extensive questions during the presentation, just ask them in the chat. We will collect them and we will discuss them afterwards. With that, Professor Tost, I would ask you kindly for your presentation.
Thank you very much, Christoph. A warm welcome also from my side. It's a pleasure doing this talk today. Christoph already mentioned the title, The Role of Minerals Mining in the Sustainability Transformation. He did not mention my kind of subtitle that I put here. I put sustainable with a question mark. And this is kind of what I, on the one hand, want to convince you of from my point of view, but that is also something that we might discuss at the very end. So let me start with a very simple picture. And that picture is something that I guess all of you use, all of you have. And I would like to ask you, and this is already something where you can put your thoughts in the chat as well. What do you think when you see the mobile phone? What do you feel when you think the mobile phone? How important is your smartphone for you, the pocket computer basically in your hands? And in that context, when you use your phone, do you think you're in a digital world, or do you think that you are actually in a material world? So I'll pause just for a second, let you think about that, maybe put some comments with regards to how you feel, how you think about your mobile phone, how you perceive that in your personal life from an importance point of view. Put some thoughts in the chat. So first thing I think about are critical raw materials in that context. That's all good. Daily used for work, not possible to live without it. So really important, I guess, like a digital extension of myself, very important. That's kind of exactly the type of reactions that I wanted to get from this. So I think bottom line is they are important for us. They are part of our daily lives. They are the digital extension of ourselves. So let me bring up another picture. Same question. What do you think? What do you feel when you see this picture? How important is it to you? A good comment already, linkage of the digital and the physical world. Yeah. By the way, this is a copper mine, open pit mine, copper in Australia. Just for the mining people in the course. A rich digital world through materials, and for this, critical minerals are required. Yeah, Ephraim, good point. Copper, by the way, is one of those critical minerals. So there's a thought about when you have those open pit mines, then you have a lot of waste materials and so-called tailings, sort of the fine sands from processing when you further concentrate the copper ore as well. And kind of where I was going, or where I want to go with those two pictures is those two pictures basically connect this digital world, as somebody already said in the chat, connect the digital world with the material world. And when you use the smartphone as an example, this slide is a couple of years old from Canadian mining. You see that there is actually more than 40 mined metals, rare earth elements in one such mobile phone, one such device. And you can actually see where the sound is coming from, what you need for that, the touch screen and the swiping, what you need for that, the earbuds, the iPhone case, and the electronics within as well. So more than 40 materials that are being used for just one mobile phone. And I put 4 of those materials sort of in red circles: gold, tantalum, tungsten, and tin. Any guesses? Again, put your thoughts in the chat why I put those 4 in red circles. Three TGs, Milutin, absolutely correct. Can anybody explain what Milutin could mean with 3 TG? Maybe use another very short 2 words for that. So the 3 TGs, tin, tungsten, tantalum, and gold, exactly, Olivia, they are the conflict materials according to the European Union. Yeah, so there is special regulations in place within the European Union where import of those materials from the Democratic Republic of Congo has to follow certain very restrictive and rules with regards to where this is come from, because those 4 materials, the 3 T's and G, are actually used to fund conflict in the Democratic Republic of Congo. So I just want to point that out at this stage, and we'll get back into this in a little bit later on in further detail, that whenever you have your mobile phone in your hand, it also includes the conflict minerals as per the European Union conflict minerals regulations. So they are part of our daily lives. They are of relevance. And with that, we should be aware of that, and they need to be part of our decision making and our process, the thinking processes as well, which very rarely is the case, because the large majority of people, when I ask that question, what they actually mean, they have no idea about that. Of course, some of you, Milutin, etc., you work and you study in this context, in this field. Therefore, of course, you can make that connection already. But be aware that in your mobile phone and in your other devices, your computer, your laptop, your iPad, etc., they are part of those devices as well. So the next point I want to make, just again, use the chat. What's the price of an iPhone? Let's say it's somewhere in the range 600, or of a smartphone, it's somewhere in the range on average, somewhere in the range of 600 euros in our case. Put in the chat what you think is the value of the materials, those 40 plus materials that are in your phone. Tell me, let me know what you think is the value of those out of the 600 euros that the iPhone costs overall. Okay, 100 euros, 50 euros, 2 euros, about 3 euros, 10%, 70 euros, So the range is from 2 to 100. 10% would be 60 euros, so 2 to 100. The 2 euros is actually very close. Yeah? So it depends a little bit on the type, but 1 to 2 euros, US dollars, that's about the price, even with the current very high prices. So I put 31 grams of aluminium there. I actually checked that just yesterday. The aluminium price at the moment, 2,900 US dollars per ton. So calculate that down to the 31 grams, you're at 0.1 cent per mobile phone. Yeah? And the very large majority of those 1 to 2 euros is actually gold. And then when you think about sort of that value, there is about 4 or 5 out of those 40 materials at the moment where recycling makes economic sense. So it's about 4 or 5 of those materials, of the 40 plus materials in your iPhone, where at the moment recycling makes economic sense, even with the current high prices for mineral raw materials. It's slightly different, of course, for instance, for cars, e-mobiles, e-cars, where because of the battery value at the moment there, the price is much higher, and therefore the part or the contribution of the raw materials to the overall price of the product is higher than it is for mobile phones. But the point I want to make, and this was also expressed in the name, we consider our mineral raw materials as commodities. We treat them this way, which is very, very, from my point of view, very unfortunate. We don't value them because in economic terms, they don't have values in our products anymore. And we lost that connection to those materials in the things we use, the things we own. So how much are we actually using? And I know this is a very, very busy slide, and I don't want to go into all the details here, but this is sort of the key summary slide of the world mining data that on an annual basis, our Austrian Ministry of Finance is actually providing, which shows the global raw materials production. Well, it shows almost all of the raw materials production, except for one very important sort of category of mineral raw materials, and that is the construction materials. That is not shown in this graph. Construction materials is actually the largest number, and there is no exact numbers out there. There is just UN guesses out there, informed guesses, and they actually are now thinking that we use or we produce, extract about 50 billion tons of construction raw materials per year. 50 billion tons per year. This is the second largest mass stream that we as mankind move around in the world. The largest is water. We pump a lot of water for agriculture and drinking water, etc., industrial water. That's about 10 times the amount that we actually mine for construction material. But this is the second largest stream that we as mankind are moving around. 50 billion construction materials, and then the world mining data gives you all the other numbers. And I just want to point out sort of overall production numbers in the world mining data 2025, which is always sort of 2 years back. So the 2023 number, production is about 19 billion tons in 2023. And then when you go into sort of this graph on the side here, the very largest number, which is roughly 17 billion tons out of those 19 billion tons, is fossil fuels. Coal, the largest part of that, oil and gas are the largest part of sort of those other materials that we mine. And then we're about 2 billion tons of iron ore and steel making metals that go into sort of the steel production. And then we have industrial minerals with less than 1 billion ton, and the rest base metals and precious metals is very, very small parts and contributions. Where do all the materials come from? And you can, when you look at sort of the left lower corner, China is indeed now the largest producer in about 30 different commodities around the world. So that goes from iron and ferroalloy metals all the way to mineral fuels, so coal, via precious metals, gold, industrial minerals, etc. So China, largest miner. Staying with China for just a second, they are also now the largest processor for an additional number of raw materials, which is from a European and from a geopolitical point of view, we'll get to that a little bit later again, even more concerning that they have now captured larger parts of the value chain beyond just sort of the extraction of the raw materials as well. The other point I want to make here, or what I want to point out, is sort of where are we mining beyond China, and you can look at that sort of the deltas in the last 25 years. And what you can see here, obviously, a very large rise in Australia as well as in Asia, and a decline only in one part of the world, and that is Europe. Yeah, and here comes a big but, again, linking that to the fossil fuels here, to the mineral fuels. That increase in Asia, very much so driven by coal. The decrease in Europe, very much so driven by coal as well. Yeah? So we had a decrease in metal production, industrial mineral production as well, but it's not as strong as it is for coal. So from a sustainability point of view and from a sort of climate change point of view, from a European perspective, that is good news. I'll come back to that again at the later stage from a global point of view, however. So key message from this, we are mining ever more because we are using ever more. And when you actually divide those numbers that I just talked about and presented, roughly 70 billion tons mined per year, divided by 8.4 billion, somewhere in that range, people living at the moment, and you get to 8.59 tons per head that we are actually using. When you compare that to the Austrian number, that's more so closely to about 20 tons of mineral raw materials per head. From the baby to the grandmother, we're using about 20 tons per head every year. So the bottom line, the point I want to make with this slide, many of you or some of you might think that we already live in a digital world. We live in a material world, and ever more so now than ever before. Yeah, we're using ever more, and we don't see any change in that trend that the extraction numbers are continuously going up. So why does that matter? And now I'm going to switch into sort of the broader sustainability point of view. And this is some numbers from research that I did some years ago already. I looked at the CO2 emissions, the water use, the land use, and consequences on or impacts on biodiversity for just 4 metals: iron, aluminium, copper, and gold. Those 4 metals, both from a mining mass point of view, as well as so how much are we extracting as an ore on an ore basis, as well as from a value point of view in terms of how this is sold and how much of the value of all the metals, all of the mining products they make out. This is more than 90%. So those 4 metals make up more than 90%, both from a mass mining point of view, as well as from a value generated point of view. And when you look at the CO2 emissions of mining those 4 metals, they are about less than 1% of industrial CO2 emissions. But when you then transfer those ores into the metals that we're using, so steel and aluminium, they start to matter. Yeah, then we talk about roughly 13%, 2016 numbers, so they're a few years old. 13% of all of our industrial emissions. Add to that again construction materials, cement making, then you're in the range of 20+% of mineral raw materials and their transition towards the products that we are using, 20+%. Add to that the fossil fuels, and of course, then the number is a huge one overall anyways with regards to the products and our contribution to climate change. So mining matters with regards to climate change. Same I did for water, and it's less so of an impact. Here, when you look at global water use, industry is only 19% of the total, and out of those 19%, steel and aluminium is again 6%, mining is again less than 1%. So again, steel making, aluminium smelting, they matter on a global scale, but overall industry is little compared to agriculture, which is the largest water user in the world. But point I want to make, so less than agriculture, but nevertheless, again, mining and the production of the mining products, the metals, matter on a global scale. The numbers for land use, where you actually think mining has a big impact on land, are less critical. So for those 4 metals, land use is in 2016 was less than Belgium. So on a global scale, that number is not as significant as in comparison, for instance, to CO2 and to water withdrawals. Here comes the big but. Where we mine matters, however. And this is sort of the last graph here on that slide. When you look at, again, where does the bauxite mining happen in terms of biomes, bauxite is much so, the majority of it is mined sort of in the tropics. And when you look at that, then you get sort of into tropical forests, tropical, both coniferous and dry broadland forests, but also tropical, subtropical grasslands, etc. And going through that, copper is different because copper is a lot in deserts, gold and iron ore, kind of a mixed bag. But the point is, a large percentage of those 4 metals is actually mined in biomes that are biodiversity relevant and biodiversity rich. So whilst we don't use much land overall on a global scale, we use valuable land from a biodiversity point of view for the extraction of at least those 4 metals. So point I want to make with this slide, mining, even just those 4 metals, matters on a global scale. So again, when you add to that construction materials, when you add to that the fossil fuels, the number is even higher and therefore matters even more so from the environmental impact just on those kind of 3 or 4 categories that I've been discussing. So another viewpoint on this, why does mining matter? And this is going sort of off in a social or socio-economic point of view. And I just chose, I could have chosen other sort of viewpoints on this, but I just chose sort of what is happening at the moment with the Russian invasion in Ukraine. I guess there is a very large reason. I was actually at the conference just last 2 weeks ago in Vienna that was discussing exactly the geopolitics of raw materials from China's rare earth export quota all the way to this picture here, the Russian invasion of Ukraine. And what you see on this sort of in red is the currently occupied territories in the east of the Ukraine. And when you look at that, and when you then look at sort of the critical raw materials, you can actually see that a very large percentage of those critical raw materials is actually exactly in that area. So Luhansk, Donetsk is where the mineral riches of the Ukraine are. And in that conference week before last, that was discussed as, of course, one of the key drivers on why Putin invaded, number one, but also why Putin wants exactly those two provinces as part of any sort of negotiations that he's now sort of kind of starting to put on the table. He's insisting that both those provinces in totality should become part of Russia. Yeah, and particularly, and I can connect that again to what I said before, when you look at sort of the rare earth elements in the Ukraine, and then bringing in the US here as well. You might have read about that deal that Trump made with the Ukraine, sort of help in exchange for the rare earth elements. You see that very large north to south green area in the conflict area that actually shows rare earth occurrences in that area. So they are a large part of sort of the mineral riches, and they play part on this, even in the broader context, not just Russia, Ukraine, but it also brings in the US into that sort of geopolitical aspects and matters as well. And I could, as I said before, bring up other sort of conflicts or why raw materials matter from ancient times, sort of the colonies in Latin America with gold being extracted in the various Latin American countries and brought to Spain, all the way what Belgium did as a colonial power in the Democratic Republic, now Democratic Republic of Congo, Belgium Congo as it was back then, all the way up to sort of blood diamonds and the already discussed conflict minerals, 3TG, as they are sort of in the European Union. So all of those points, or the key point I want to make here with this slide, mining and the raw materials, the mineral raw materials, they still matter in geopolitical terms, and they still very much so influence geopolitics on a global scale. So how does that actually feed back into sustainability? Let me first start with what is it? And if I were to ask you again, put your thoughts in the chat. What does sustainability mean for you? What is it? I put sort of a photo here that shows washing hands with a piece of soap. And I heard that expression many, many years ago, sort of when I was asked that question, or I was discussed somewhere else, what is sustainability? It's that piece of soap where you kind of put it in your hands, but you can never really grasp and you can never really hold it. It's kind of always slippery. So it kind of escapes a very clear and a very strong definition. And I guess if I was to ask all of you for your thoughts, your definitions, we would get maybe not different answers from all of you, but we would get a large number of different answers with regards to what it actually means. So let me bring you back to what I think it means, or what I think it should actually mean. And the first thing I want to do is we need to get away from the Brundtland definition, which many of you have heard and which many of you would probably bring up if I were to ask you. And this is sort of on the left-hand side. Gro Harlem Brundtland was the chair of this World Commission on the Environment and Development, which in 1987 came up with this report called Our Common Future. And that report included the first definition that you see on the left-hand side: meeting the needs of the present without compromising the ability of future generations to meet their own needs. From a scientific point of view, I would consider this definition as outdated. And we have since moved from this focus on needs, as in particularly material needs that are highly relevant, of course, in our raw materials conversation. And what I said before, that we mine and extract ever more. We need to move away from just that conversation towards inclusive well-being as the goal or the definition of sustainability. And some of you might actually be in my lecture. We there teach this framework that Madsen, Clark, and Anderson came up with in 2016, where they actually talk about the goal of sustainability being inclusive well-being, and then they defined a number of constituents, with material needs being only one of the constituents of well-being. So our health, opportunity that we have in our lives, community and security are the others that they came up with. And you can actually see from that, you might be the richest person in the world with having islands and many cars and private jets, whatever it is in the world. If you have cancer and that cancer cannot be cured, you are not well off. So your well-being is probably not given. Just to use one example on where this was going and what they mean with this. So more constituents to well-being than just material needs. And then there is determinants. So how can we actually get there? What contributes to those needs? And there you can actually see there is again a number of those determinants, and natural capital, mineral raw materials being part of the natural capital, being one of those determinants. Social capital, manufactured capital, knowledge capital, human capital are the others. I don't want to go into all of the details of those, but usually we turn those, the natural capital, the mineral raw materials, into manufactured capital, or we use that to create knowledge capital, to create human capital. We have this computer. Via this computer, I can actually talk to you today about raw material sustainability. That hopefully helps with your knowledge capital. Give you just one example. So one aspect, from needs to inclusive well-being. Second aspect, another aspect, we need to do sustainable development or human development within environmental limits. And we can now quantify all of those. So what you see on the left-hand side is what is called the Great Acceleration. That very good for us since World War II, basically, a large number of socioeconomic indicators. And you can see here population, GDP, direct investment, energy use, dams, water use, paper production, transportation, etc. We see very rapid non-linear growth, which is a good thing, I would argue. So from a socioeconomic point of view, a very large majority of the people living today, out of those 8.4 billion people, are better off than the people living in the 19th century or the early 20th century. Yeah, here comes the big but. That has happened with a similar trend to the Earth system. So when you look at then Earth system indicators, CO2 emissions, nitrous oxide emissions, methane emissions, very similar growth since the end of World War II. But in this case, that growth in those indicators is negative. Yeah? So much so that on the right-hand side, in many of those areas, we are actually now exceeding what Earth system scientists, Robström, Richardson, Stefan, just to put some names out there, in this concept called the planetary boundaries, we are exceeding 6 out of the 9 planetary boundaries that they actually defined with regards to environmental indicators. So you can see, for instance, climate change up there You can actually see biosphere and land system change up there. You can see water up there. You can see biogeochemical flows up there. And those are the areas where we have already exceeded the planetary boundaries. And make no mistake about that, planetary boundaries means, in this case, a safe operating space for us as humans. Yeah, the Earth doesn't really care whether or not we stay within those boundaries. New equilibriums will actually happen. New equilibriums will sort of kick in. They might just not be life-friendly for us as humans, as the last 12,000 years or so, end of the last ice age, have been, where we as mankind prospered on this earth, and where we've moved from just a few million or some 100 million people up to 8.2, 8.4 billion people as it stands now. So we were able to prosper, and we want to keep in that space in order to continue prospering. Yeah? And those Earth system scientists with the planetary boundaries, they actually say there is now large risk that we actually reach tipping points. You might have heard that expression already as well, where the new equilibrium, once we pass those tipping points, is completely different. And it might not be as life-friendly or as human-friendly as the current equilibrium in the safe operating space that we've enjoyed in the last 12,000 years has actually been. And this is the big risk that they are actually arguing about, and they are saying that we are facing by having now crossed 6 out of those 9 boundaries. Yeah. So the socioeconomic trends, a good thing, but so far we've done that at the cost of our Earth system, at the cost of our environment. And we have to get back to human development within environmental limits, as expressed, for instance, by the concept of the planetary boundaries. So what that means is, from a sustainability point of view, we actually have to move from these pillars, and that we actually have to balance those pillars. And if they are in balance, sort of the social, the environmental, and the economical phase, pillar or cycle, then we are sustainable. We actually have to move to a view, and Kate Raworth, an economist, did that a couple of years ago, where she actually said we have environmental boundaries or an environmental ceiling, and we have a social foundation, so a social minimum, those opportunities, the health, etc., that I mentioned before, those parts of well-being, they have to be given as well. And then if we reach the social foundation, and then if we stay within the environmental ceiling, that's the place where economic development can actually take place. And then we can talk about an inclusive and sustainable economic development, i.e. sustainable development. Yeah. So from needs all the way to inclusive well-being, and doing that within an environmental ceiling and by overstepping sort of certain social foundations. That's where our economic activity should actually take place. And in order to get there, we've started defining some sustainability transitions. And I just put up 2 examples with that. You might be familiar with the Sustainable Development Goals, or SDGs, of the United Nations. So that's sort of the global transition that we are going through at the moment, with those 17 goals that you might have heard out, the 17 SDGs that you might have heard about already as well. And I just want to point out 2. One of them is number 13, climate action. This is where the Paris Agreement on limiting climate change comes in as well. And by the way, just a sidestep, the 1.5 degrees that we should aim for on where to limit climate change in terms of warming is roughly where Rockström and the others defined the boundary condition for climate change in the planet, in the planetary boundaries concept that I presented just before. So there is some linkage to science in that political goal, but the compromise then was, of course, the 2 degrees. And as you might have read already, the 1.5 degrees in 2024, for the first time, we've actually exceeded that temperature on an annual basis, basically. I also mentioned here the biological diversity, so life below water, number 14, and life on land, number 15 SDG. Again, there is already some treaties in place in addition to the goals that are supposed to deal with sort of that particular issue, because at the global scale and the UN have already recognized those well before they put the SDGs in place as globally relevant transition requirements or transition goals. Another thing I want to mention with regards to the SDGs, they are to some extent, and I mentioned as an example before, the 1.5 and the 2 degrees in the Paris Agreement, but to a large extent, they are actually political compromises. And science would have gone much further with regards to where we have to go from a sustainability point of view in the context of what I presented before. Yeah. So from a scientific point of view, the SDGs are not going far enough. So they can only be seen as the political compromise. They can only be seen as a first step with regards to that transition. And in addition to that, I put up another example, the European Green Deal, that actually was already to some extent going further than the SDGs. For instance, one of the goals in the European Green Deal was for Europe to be carbon neutral by 2050. That was going beyond 2 degrees, 1.5 degrees that were part of the Paris Agreement. Let's become carbon neutral by 2050. Some of you might now say, yes, but the Green Deal is under discussion again. We now have the competitive clean industrial deal that is actually one step back from this. Absolutely right. We're not moving fast enough, and we're probably not moving there. But that goes back to the already mentioned before geopolitical context as well, which again, we can discuss a little bit later, is actually something to consider and is rather scary from a pure sustainability viewpoint at the moment. One other thing I want to bring up in this context is, and this is actually from or around the original Green Deal publications from 2019, is that picture of the European Commission of the circular economy and how they see the circular economy. And I like that very much because there is always this left-hand side ear when you look at this from a raw materials extraction point of view. And of course, you still have that very small error with regards to residual waste. But that kind of shows the direction of where we actually have to go, or where we should go with regards to the circular economy. Yeah, but you still have that ear there at the raw material extraction that we still need, even in that view of the Green Deal of 2019, the European Commission, some raw material extraction as well. And yes, Olivier, you're absolutely right. The Circular Economy Act is supposed to come up next year, but I will make some arguments in that direction if the question then is, what does all of that mean for mining? What does all of that mean for mineral raw materials? And link that back to what we need to do in sort of the raw materials and the mining space over the next years, and actually over the next decades as well, and what we at our chair here at Montanuniversität Leoben are doing as well. So let me start very briefly with the non-renewability of minerals, because usually when I go into sort of that sustainability space and that sustainability discussion, this is the first thing I hear. Yeah, mining, mineral raw materials, you could also call them non-renewable materials. And that's kind of a killer argument. Mining cannot be sustainable because the mineral raw materials are non-renewable. My argument that in this is, you're absolutely right, absolutely correct. They are non-renewable, but when you look at the numbers of current use and even projected growth rates, we will not run out of the non-renewables. Yeah, so I brought up some examples. I brought up lithium because it's very hot at the moment. And that number, by the way, the 240,000 tons, I actually updated this number only yesterday in previous slide where I used this graph. The number was 2017, and it was, I think, 80,000 tons. So 3 times within just 8 years. 3 times the number within just 8 years. But when you compare that to the highest resource number in that graph from 2000 and United States Geological Survey 2016, where the resource is roughly 40 million tons, we have about 200 years of production left. Yeah, and even if there was growth, that number goes down. So I looked at copper. When you look at reserves, resources, and even model-based resource estimates, much bigger number when it comes to what is left in the ground at the moment. So even from a reserves point of view, that number is close to 1 billion tons. Divide 1 billion to the 23 million tons that we are producing at the moment, and the finite nature of copper is not an issue at the moment, I would argue. So then I went into ChatGPT and just yesterday asked it which of the raw materials, the mineral raw materials, is actually the tightest from a current known resource versus production point of view. And tellurium is actually the tightest, and there the number is 32 years of reserves left. Yeah, so reserves is the number where it would be economic to mine them at the moment. So economically, we have 32 years of production left of tellurium. And I would again argue, in the context of sustainability, particularly with regards to planetary boundaries, this is not the first issue that we should focus on. And by the way, when mining started looking into what sustainability should mean to them some 25 years ago in the Global Mining Initiative, that was also one of the key findings of the Global Mining Initiative. We should not worry about the non-renewability of the minerals themselves. We should worry about the consequences of our processes and how we use them. And I'll come back to that in just a minute. So then the argument would actually be, let's recycle as much as we can. Circular economy. Yeah, I would say again, yes, we have to do that, absolutely. But I'm showing you now some work that our vice rector, Helmut Andrekovic, did some years ago. Yes, this is from 2012, but I could update those graphs to the recent years and it would not change much in terms of consequence. The secondary, the recycling numbers have gone up and are going up, but the total is growing much faster. Therefore, the primary production, i.e. what we get from bauxite, alumina, aluminium, smelting, is growing faster than what we can recycle. And the key reason for that is because we're still in this growing economy. China's still catching up, India only starting to catch up, and Africa not yet having started to catch up. So absolutely we need to recycle, but for the foreseeable future, the next years, the next decades, we will still need primary production of mineral raw materials as well. In the current environment, ever more so than what we've had in the past. That's where you all get those sort of growing numbers, and I'll come back to them in a second as well. So my key and my bottom line on this, we will still need mining, but mining needs to look very, very differently. And what that means is, again, starting from a raw materials point of view, we need to differentiate what we mine. And I'm showing here just one graph from, again, the European Commission. This is the material foresight that they see only for renewable energy production and e-mobility, and only for Europe. And when you look at that, lithium times more from 2018, I think, is the base year, 6 or 20 times more up until 2030, and up to 60 times more up to 2050. Yeah, goes back into sort of those growth numbers that I showed already before. So the expectation and the foresight at the moment is, when it comes to the digital transformation, when it comes to the energy transformation, we need way more of the raw materials that actually enable that transformation. So I would argue those we will need. We need less fossil fuels. Yes, from a European point of view. No, still from a current situation point of view, when it comes to China and to India. They actually think, and OECD and International Energy Agency forecast that as well at the moment, that coal production, particularly based on India and China, up until 2050 will continue to grow. And indeed, we had visitors from India at our chair week before last, and they actually said that they are expecting coal production in India to grow from 1 billion tons a year to 2 billion tons a year in the next 20 years. And from a climate change, planetary boundaries point of view, I would argue that is scary. Yeah? And I would challenge whether or not, as mankind, we can still afford to do that. So that's why I put less demand for coal with a question mark. From a European Union point of view, very clear, we, for the last decades, have already started getting out of coal completely. And the plans are there to finish that process before 2050. So Germany, Czech Republic, Slovakia, Poland, the largest coal users still, the plans are there to get out of coal in the next 1 or 2 decades. Overall, still growing numbers. That's why I put that question mark. As I said before, from a geobiophysical point of view, planetary boundary point of view, very scary. And the last point I just want to make in that context, can we still afford to mine for luxury goods? Yeah, and I put gold and diamonds there as examples. And by the way, sidestep now, I did not talk about sort of the byproducts and the waste that we generate. That's roughly in the range of 50 billion tons per year as well. So those construction material numbers that I presented, the waste generated is very much so in the same range. So every gram of gold, for instance, 1 ton of waste. So 1 ppm is about the concentration for gold as current sort of average production extraction numbers go. For diamonds, 1 carat, 0.2 grams, about 200 to 250 tons of waste material. So again, in the context of planetary boundaries, I would say, can we afford to still do this? I leave it in the room. I leave it up for you to think about that for now. But so that's the raw materials, but also mining itself needs to change. And this is sort of what we are doing at the moment here at our chair as well. First thing, companies, the business models needs to change. And I just put as an example here, Boliden, one of the larger European mining companies. They don't see themselves as a mining company anymore. They see themselves as a metal provider. Yeah, and in the case of copper, for instance, they don't differentiate anymore what goes through their smelter, and roughly 50% of what goes through their smelter is now primary copper ore, and 50% is actually secondary copper containing scrap materials. Yeah, so that I think is a big part of the changes need to happen as well, that the sources, primary, secondary materials, and what I said before, yes, we need the recycling, and yes, we need circular economy. That is already happening to some part, and to a very large part, I think it is within Europe. because we don't have all the mining we would actually require and need in order to fulfill our needs or requirements at the moment. But I just want to make one other comment in this. So technically, all of that is possible, but also we need to put the economic incentives in place as well within our system, that the economic system itself is not a linear anymore, but the economic system supports also how we think and how we deal with our raw materials. And Olivia in the chat before pointed out the critical, the Circular Economy Act hopefully goes in that direction as well, that it encourages sort of that change in the economic system as well, from sort of that linear thinking towards sort of an circular system. So it's not just about the technical aspects that we need to change and put the recycling systems, etc., in place, but the economic incentives also need to support all of that. And the mining process itself, and this is why I bring it back to sort of our chair here, needs to change. And we did this project called SUMEX, Sustainable Management of Extractive Industries, some years ago, an EU Horizon project where we coordinated this project, where one of the outputs was this roadmap, where we put in place how the mining process itself needs to change within the next decades. And I just put forward some examples here. So by 2040 up to 2050, the mining process itself needs to become carbon neutral. We need to find solutions for closing the cycles. Yeah, so that mining waste that I mentioned before, the 50 billion tons, we need to find ways on how to deal with them. And it just so happens that 50 billion tons coincides with construction materials, the number I presented at the forefront. So here is a challenge for all the circular engineers in the room. We need to replace one with the other in the next decades. It's not going to be easy from a location point of view. It's not going to be easy from a qualitative point of view, but we certainly need to work towards finding those solutions in the next decades. And that's something we put on that roadmap as an example as well. So some concrete examples at our chair: mine planning and artificial intelligence. Mine planning, all of that is done very much so using digital programs, SERPEC, data mine, you name them. But now the next step is obviously to use AI to optimize, to support those processes, but also to optimize the mine design, the mine planning process as well. I already mentioned electrification, zero or carbon neutrality in the next couple of years. Close to home, I used this example from Erzberg. What they did there already a couple of years ago, they actually put those trolley systems on their ramps. So the largest diesel consumption parts of their truck fleet, the waste material, bringing them to the waste dumps is about, I think, 3 to 4 kilometers uphill. So they put the trolley system there in place there, so that they reduce the CO2 emissions from diesel usage, and now they replace that with electricity, basically, which, by the way, comes to a large part from photovoltaic systems that they put directly on their site, that they directly put on their not used anymore tailings disposal areas in parts of or site, parts of their land, parts of their operations. There is again a trend towards conveyor belts, electrically powered conveyor belts. So bottom line, there is a trend towards electrification. Another example, trend toward robo-miners. You see one of those large haul trucks on the left-hand side. You might notice that that haul truck shown there from Komatsu doesn't have a cabin anymore. So there is no intention anymore that there is a human driver on that machine, but it's a fully autonomous robot, so to speak, that is driving along in a mine site. And again, one of our projects, RoboMiners, the idea was originally in that scratch concept of the project, you see spiders. It happened at the very end that the prototype developed in the project was actually more so of a worm rather than a spider, but the idea was to send robots in that selectively mine, and then you actually have slurries of just sort of the ore of the material that you want to extract without generating too much waste materials that are then pumped via borehole to the surface, and then you have the further processing there. So very, very selective mining that only takes out sort of the ore and not additional waste materials to reduce costs of all of the follow-up processes, basically. In Europe, what we also see emerging now is a trend towards underground mining. So we are currently researching and looking into how to make underground mining and particularly mass mining cheaper. And I just bring up this example of race mining that we developed together with LKAB, the Swedish iron ore miner, where this is bottom line, the latest patented new mining method. So LKAB and us together, we are kind of inventors in this one, patented this mining method. But the point I want to make here is underground mining very much so back on the agenda, particularly in Europe. We're a small continent. Land is a rather scarce resource, so large open pit mines will not happen anymore from a social acceptance point of view going forward. Hence, underground mining and making it cost competitive with open pit mining is also something we're looking into ever more. Very last point in that context of sustainable mining, post-mining, also something to be considered way more, not just from a closure of the mine and then rehabilitate the land, make it safe, make it look nice anymore, but we need to get much better in terms of also then using or seeing the closure of a mine as an economic opportunity or as a further post-mining development opportunity, whatever that can be. Economic, can be social, can be also environmental. You create a new landscape and their biodiversity opportunities might be much higher in today's rather cultivated world than they used to be before as well. And the example I'm showing you here is the Eden project in the UK, in the Cornwall, which used to be a clay pit, a clay mine. And now what you see here there with those biomes, with an educational center, etc., is very much so a very large tourist attraction. And they actually now make more money from that tourist attraction in the clay pit than they ever made with mining and processing the clay before. So, and the point I also want to make on this, it was very creative people who thought about that closure and post-mining opportunities. And I think we need to think way more outside of the box with regards to closure and particularly then post-mining use of that land as well in a sustainability, in a broad sustainability context. And this is sort of where I wanted to go with my presentation today. I think that mineral raw materials in the context, as I tried to explain it today, and mining in that context, as I tried to explain it today, can be sustainable, but I want to put that forward as a question to you as well. And so can mineral raw materials, can mining be sustainable? What do you think? Thank you very much for your attention, and I'll open the floor up for questions and for discussion.
Thank you very much, Michael, for your very interesting presentation, very insightful. Yeah, we have some time now for questions. Either you can directly write them in the chat, then I will read them out, or Michael can also see the chat. Or if you want to even take part actively in the discussion, we can also bring you up to stage here. So just please write in the chat if you have any questions. For now, maybe one question from my side. We heard a lot in the last years also about lithium resources and maybe also reserves. You can judge that better than me in Europe. Do you think mining these will come in the future, or do you see that more as like, you know, a headline, but not really projects being started for various reasons?
So there is now a large number, but there is now a number of projects that are being started and that are being advanced. And there is also political will, and there is political support for that as well. I briefly mentioned, I think I mentioned the Critical Raw Materials Act that the European Union has put in place early last year, 2024. And part of that Critical Raw Materials Act are so-called strategic projects. And projects, mining projects, but also processing, etc., value chain, down the value chain projects, they can apply for strategic project recognition within the European Union or under the Critical Raw Materials Act. And in the first round, don't exactly quote me on this, but I think it was 46, somewhere in that range, 40 plus projects that applied from within the European Union, and about half of those projects were actually lithium projects. Yeah, both lithium mining projects, but also down the value chain processing projects. Portugal, Spain, Germany, Finland, I think, are just some of the countries and where they are located. Very easy to follow up on critical raw materials or strategic projects. Google them, and then you can see where they are. But about half of those that have now been designated are lithium projects. What this means is, under the Critical Raw Materials Act, they should be permitted within 2 years. So very rapid permitting, that they can actually then go into sort of the next step from planning phase towards execution phase, basically. They are supposed to have easier access to funding. So if they are recognized as strategic projects now via European, don't quote me exactly on that, but European banking system, EBRD, or however they are called, those projects should have access to this as well. Another element of this, so that's sort of within the European Union. Some of those projects I actually think are also competitive. So from an economic point of view, they are competitive. Outside the European Union, there's also one project that is designated, that is a lithium, but also a boron project. That's the Jada project in Serbia. That's also now dedicated a strategic project under the Critical Raw Materials Act. And I would consider this deposit there a world-class deposit. Yeah, so that for sure is competitive from a global point of view with other lithium deposits. And the largest, or the current lithium mining, happens in Latin America, particularly Chile, but also in Australia.
Thank you very much. I saw in the chat in the meantime that we have another question also with regards to lithium, and I would like to continue with that from Gerhard. Mines are often in very dry areas. Are there already methods existing that can process the ores without water? Speaking about lithium mining.
So we need to differentiate a little bit. I mentioned before, sort of a large part of the lithium at the moment comes from Latin America. Yeah, production there is based on primes, and there you need water. Basically, that's solution mining. You pump water underground, and the lithium salt is soaked in that water, and then the prime is pumped up, and then from that either via sort of those large ponds that you might see from pictures, the water is evaporated, or you use natural gas to evaporate the water. Yeah, that process needs a lot of water. The second half, what is produced in Australia, and to a very large extent, the blends in Europe, comes from hard rock mining. So there you don't need that much water in the mining process itself. So different story. For us in Europe, most of the projects, not all of them, but most of the projects are actually hard rock mining projects. There is, to my knowledge, only one that is based on primes as well, which is in Germany, but there it's also sort of a co-benefit project, that it's a geothermal project. And what they also want to do there, and this goes back, long-winded answer to that question, there is now a process called direct lithium extraction that is sort of slowly getting towards the production phase. Don't quote me exactly where it sits. Somebody in the audience might know that better than I do from a processing point of view, but I think it's somewhere technical readiness 6, 7, 8, somewhere in that range, where you actually then get to mass, where we get to sort of using it in production. And that is supposed to reduce the water demand, the water requirement, rather significantly in sort of the solution mining based production as well. And that the project in Germany would be the first and only one in Europe to actually use direct lithium extraction as part of their plans going forward.
Mm-hmm. I can comment on that quickly, because we are also actively looking into this at our chair. I'm from the chair of geoenergy, from these geothermal brines. I agree with you on the number. I think they're close to making it in a production setting now, but they're still far away from a TRL 9 or so in this process. Yeah. And I think also from the latest numbers I got, it's not comparable to what the traditional mining, so to say, extracts.
Mm-hmm. So just very quickly on that, Oberrheingraben, I actually met the CEO of that company 2 months ago or so on a panel, and he talked about direct lithium extraction, but also he mentioned that it has been very difficult for them to get funding from a risk funding point of view. Europe is very traditional, and Europe does not like, or investors in Europe don't like to take those type of risks. So they were very glad and happy to get strategic project recognition from the European Union, because they now hope that with that and what I mentioned before, it makes it easier for them to get the funding as well to develop the direct lithium extraction, DLE technology, further towards sort of direct production.
Mm-hmm. Good. I would like to continue with a question, or with a comment and question from Daniel, that wrote here: mining and even green research projects, for instance, concerning geothermal energy, are met with strong resistance from the public. How can social license to operate be regained, given the non-stellar reputation of the mining industry?
Mm-hmm. Very good question. Also, I did not go sort of very deeply into social acceptance, but the SUMEC sustainability framework that you can still see there is supposed to help with that as well. So the argument I would make there is, if we change the mining processes accordingly, then social acceptance will come with that as well. Yeah. So if mining becomes sort of a regular neighbor, so to speak, with less environmental impacts, noise, pollution, water, land, less land use, etc., then the social acceptance will follow with that as well. And I give you one example. What I mean with that, we're currently involved with a project in Norway, where a rare earth elements project, where from the shape of the deposit, etc., and how the deposit is sort of located in the earth, from a sheer economic point of view, it would make sense to start production, to start extraction there via an open pit mine. Yeah, the company there put that completely out of question, because from an acceptance point of view, this is rural land close to a community, close to a larger lake that is actually a drinking water reserve for this part of Norway. It would be not feasible to actually have acceptance, social acceptance for an open pit mine. So they don't even bother starting planning with an open pit mine. We actually started planning right from the beginning with an underground mine. Yes, you lose parts of the upper parts of the deposit because you need to leave a ground pillar there to keep the surface safe, basically, and the mine, the underground mine, keep that safe as well. But that's the price they want to pay for the social acceptance. Yeah? And what we're doing at the moment, they are very openly communicating about the plans for the underground mine with the concerned community. And I think that sort of doing it this way, planning accordingly, communicating accordingly, is needed in order to sort of gain that social acceptance. Make no mistake, just one side comment, very, very quickly, briefly on that. Make no mistake, social media play a strong role in influencing that. And make no mistake, within social medias, we actually see other actors, political actors, play a role in this as well. Yeah, I've read a paper, I mentioned YADA, that lithium boron project in Serbia before, and there I read a paper some months ago from Serbian national researchers, but they currently work in Serbia, and they looked at the impact and role of social media on that project, and who is behind certain accounts that actually are in strong opposition. And they made the point in that paper that state actors from the east of us play a strong role in influencing the debate on social media, particularly on TikTok and particularly on Telegram. And that gives you an idea of which state actors I actually mean east of us as well.
Let's make a jump to the east and continue with Olivia's question, but to the further east than what you were talking about, I guess. How does China's position in producing and processing both raw and secondary raw materials affect global efforts towards sustainable resource management and the circular economy? And I guess we can also add India here as a second country with similar
I mentioned coal before, yeah, but then also, so China has a global dominant role. Whatever matters in China matters for the rest of the world. Think carbon emissions, think production, manufacturing, how much of whatever we use, how much of whatever we consume now comes from China. Think lithium batteries, think photovoltaic systems, think wind energy, etc. China matters. Yeah. So again, thinking planetary boundaries, thinking what's going on globally. If China is not on board in making those changes that I presented before, then we have a problem on a global stage. And likewise, the same thing is true with regards to India as well. So if India goes from this 1 billion ton of coal extraction to 2 billion, that matters on a global base. Yeah. China, I think, is already changing in a sense that, yes, they are still using coal, a lot of coal, but there is already studies and estimates out there that China might have peaked and that coal extraction and coal use in thermal power stations might already be on the decline, because they are adding photovoltaic systems and they are adding wind-powered system to the system in much quicker pace now than what they are doing with regards to coal. And they are even older coal-fired power stations. Christoph, again, you might know that better than I do. They are putting them out of service. And they're doing that, at least to my knowledge and what I've read, quicker than what was originally planned and what was expected, at least in the forecast of the International Energy Agency, etc. Yeah. With regards to India, with regards to Africa, etc., my hope would be that the biophysical realities, but also to some extent the economic realities, make them think again with regards to their plans regarding coal. So on the one hand, I think climate change, now all the studies with COP, the Conference of Parties coming up in Brazil, all those studies are actually being published, and we are seeing now that the last couple of years, the temperature increase is actually happening faster than the models predicted, and even the worst case in those models actually predicted. So the biophysical reality might actually bring us back to rethink those plans, but to some extent the economic realities are also doing this. I think that photovoltaic systems, wind-powered systems are now cheaper than coal-fired power plants are. So it makes much more sense to actually grow our energy demand or the consumption of energy based on our demand via PV systems and via wind systems, rather than doing that on coal-based systems.
Plus, we might add that even the base load demand from that is not covered by solar plants can slowly be covered also by alternatives. If you think geothermal may be a bit farther away, but natural gas and those can all be used also for base load coverage. And batteries coming up.
Battery, absolutely. Which again needs the minerals, as we discussed before.
Of course.
And with regards, one more comment with regards to China, I actually think that China, again, make no mistakes, you read about the mines that are unsafe, etc., and that there is still many fatalities happening in Chinese coal mines, for instance. Yeah, but some of the most modern mines these days, they are also in China now. They are spending a lot of money in research that I pointed out before, where we have just a handful of people working on certain aspects, certain elements. They have hundreds of people, even thousands of people working on those aspects and elements. So they are catching up at ever quicker speeds, and they are actually moving ahead at ever quicker speeds. You might have read about those rare earth element export restrictions. You might not have read about that they also put in place restrictions on exporting technology for processing rare earth elements. Very similar to the US limiting exports of the latest microchips. Now China is putting restrictions on certain technology that is relevant, particularly in the rare earth value chain. It's not just about the products, the elements themselves. They also now have a leading advantage in certain processing technology, or at least they say so in those negotiations with the West, with the US, etc., when it comes to trade deals. And you might have read that Trump yesterday already reached an agreement with China, at least for 1 year, with regards to rare earth elements.
Let's move to something a bit more technical again, regarding jewelry and natural diamonds. I see a comment by Christian who says that natural diamonds are facing already a strong competition by artificial ones. And I would extend that maybe a bit. Do you think the alternatives to mining, they are upcoming for sure, but with which minerals you see that a lot?
We're always looking for alternatives. So it might be switching from mineral A to mineral B, zinc, lithium ion batteries and cobalt content in those. Yeah. So cobalt is actually a lot of it coming from the DRC, so it's conflict related. So we constantly look for alternatives for various reasons. And absolutely right, Christian. Jewelry and natural diamonds is one of those areas where we're looking into this. And I think for the reasons that I mentioned before, it makes sense. Yeah, getting 0.2 grams out of something out of the earth to put it on a finger or to put it on ears or wherever we put the diamonds, and moving 200 tons of rock for that, or 250 tons, and all the energy required for all of that. For me personally, it makes no sense to do that. So if we can do that in another way, that's good. Make no mistake, so jewelry still is a luxury use. So in the broader context of if we have to get back within planetary boundaries, for me, luxury use is the first thing that has to go. So in this case, we should not spend any energy either on producing synthetic diamonds, just to put those on our ring fingers. Of course, diamonds are also used in industrial use. They have various uses there. That's a different conversation. If it's a beneficial use that is kind of relevant for us in terms of inclusive well-being, and the minimum foundation that I presented before with regards to sort of the social space.
Better not to produce some things at all, I guess, in this case. Let's have one last question again about rare earth processing, or about rare earth processing. We did not speak so far about processing in this discussion, but with China leveraging their rare earth processing, do you think this processing will arise in Europe or Australia, and would this process be environmentally, economically, and socially feasible in the so-called West?
Yeah, let me bring that again back to the Critical Raw Materials Act and the strategic projects. So my personal view on this, and again, I'd have to check now, I did not look into all the details from those that already exist, whether or not any rare earth processing is already part of this. Again, you can Google that, look it up. I don't know it from the top of my head, but from a goals point of view, 10% of mining of critical raw materials, 40% of processing of critical raw materials, and 25% of recycling of critical raw materials within the European Union. From a goals point of view, the answer to your question is yes, we have to do it again within Europe. So politically, the will is there.
Let's stop at this point. Thank you very much, Michael, for your presentation and also for answering our questions. I hope everyone got a good insight. Some of you are already in the field, working in the field. For me, that is a bit outside. It was very engaging. Thank you for that. Yeah, with that, I hope you enjoyed our first TripleM talk of the semester. I hope to see you soon again for the next one, which will probably be on the 20th of November. But just watch out for our emails and check out our website. And yeah, I wish you all a nice evening and see you soon.
Thank you, everyone. Bye-bye.